a bit of nice Jeopardy music, actually, to get it going. R.I.P. Alex. But welcome, everyone. So good to see everyone here. Obviously, things are quite a bit different from how we have done the last couple of years, but thank you so much for everyone coming today. My name is Kevin Duquette. I think most of you all know me, actually. But we're going to keep with tradition the last few years that we've done this and always get an amazing student to host. So I'd like to introduce Makerspace Ambassador, Faculty of Engineering Student Ambassador, Jason Wren, everybody.
Thanks for introducing me, Kevin. Good morning and welcome to the UNSW Maker Games Student Final. A warm welcome to our audience here with us today, both in person and virtually. Before I begin, I would like to acknowledge the Bedegal people that are the traditional custodians of this land. I would also like to pay my respects to the elders, both past and present, and extend that respect to other Aboriginal and Torres Strait Islanders who are present here with us today. I would kindly request our audience to turn off or put their mobile phones on silent. Wow, what a year it's been. Through thick and thin, our teams have made it to the end. A big congratulations to all teams for coming this far, especially during such a challenging time. Today marks the culmination of all the hard work they have put in. Our students will be the leaders of the future and have designed and built solutions that will better our society. Before we start the presentations that I'm sure we are all eager to see, there are a couple of housekeeping rules. So entry is through the front door over here, exit is up the stairs and through the back door. The fire escape is also the same as the exit through the back door. The emergency meeting point will be on the University Mall, and the washrooms can be found on ground floor and first floor. There is a QR code to scan, so if you haven't already, please do so and sign in. Face masks must be worn when seated. Microphones will be sanitized between every team, and please follow physical distancing and limit contact. It's always good to go for an elbow or a fist bump instead of a hug or handshake. Now I'd like to introduce our amazing judges. We have Senior Lecturer Dipan Kundu, who is the Academic Director of the Maker Games, Ms. Laura Earle, who is the Program Manager at UNSW Founders and Michael Crouch Innovation Center, Ms. Tamara Martin, who is Industry and Innovation Manager for the UNSW Energy Institute, and Professor Julian Epps, who is Head of School at the School of Electrical Engineering and Telecommunications. Moving on to the schedule, at 10:15 we'll start the student presentations. Then we'll have a lunch break, and we'll come back at 12:45. At 1:15, we'll have the second wave of student presentations. At 2:30, the presentations will finish, and judges will start deliberating. And at 2:45, prizes will be awarded, and the event will conclude. With the timing for presentations, at 4 minutes, there will be a double tap, and at 5 minutes, a triple tap. For mics and clickers, when you are presenting, please collect them from Joe on the side, and when you are done presenting, please return them back to Joe. Without further ado, I would like to invite the first team, Assistive Technology and Seating 2.
Okay. Consider this. Nice, beautiful, sunny day. You're out at the park when all of a sudden, a cyclist runs into you. You're knocked down to the ground, dazed. You push down on the ground to try and get your bearings, but you can't. Your hand isn't moving. Your legs aren't moving. You can't feel anything. Your life has just been changed permanently. Accidents resulting in spinal cord injury are upwards of 350 new cases in Australia per year, with a large majority affecting young adults and teens. Navigating the post-accident lifestyle is often very difficult, physically and mentally. So how can we help? Hi, I'm Miguel, this is Hugo and Kath, and we're speaking to you on behalf of Team Retina. Our primary goal is to improve the quality of life for those who have sustained spinal cord injuries resulting in quadriplegia. Our mission is simple, to develop a wearable assistive device as an attachment to powered wheelchairs to give back control to those people.
Our competition is restrictive and or undignified. The sit and puff and change controller are literally in your face, making social interactions more difficult and definitely holds a hygiene risk, especially since it's difficult to wear a face mask. The head array is bulky and restricts vision to the side. To get around this, we designed our product in a sleek pair of glasses, bringing social confidence to our users and a clear vision of what's around them. During our research, we interviewed over 30 potential stakeholders, finding that safety and accuracy were the most important factors for our market. We also determined that head tilt controls were appropriate for our control system. Using this information, we designed the Retina wheelchair control system, a head-mounted control system which converts head tilts to joystick controls. We can see a quick demo here out the front where Adnan will tilt his head and the wheelchair will follow. As you can see, it's getting a bit shy and trying to run off a little bit, but it's generally following his head directions. Our device is special because it actually interfaces with the existing wheelchair infrastructure, which means it doesn't require any TGA or FDA approval, meaning we can bring our product to market faster.
The Retina control system has also streamlined the installation process for care providers, meaning less time spent being dependent on others. It is also compatible with almost every powered wheelchair in the market and features audio feedback directly from the glasses. Now, the team at Retina recognized the importance of maintaining appearances as a way to get a better sense of autonomy for the user. It was with this thought that we used the form factor of glasses. It is common, non-intrusive, and very aesthetic. With the glasses, we are able to restore the dignity of our users.
Investors can have a peace of mind knowing that that the system is modular, expandable, and future-proof. It is also expandable to other industries as well, such as the gaming industry. As the system is not a medical device, this lowers regulatory hurdles, lowers approval costs, and increases profit margins. For our investors, this means a higher rate of return. So far, we've reached out to 27 potential customers who have demonstrated an interest in our product. From there, we aim to expand to New South Wales and then expand globally to impact the lives of 60 million people worldwide. We're currently looking to apply for government grants to work on our prototype to turn it into a fully fledged product with intellectual property protection. We expect to be financially profitable at the end of 2022 with increasing market control. So far, our team consists of 6 motivated engineers who have specializations in mechanical, mechatronics, computer science, and biomedical engineering. Come talk to us if you are interested in impacting the lives of others.
We designed an effective wheelchair control system, but more than that, we changed the game, focusing on our users' needs as much as the controllability, bringing our users control and independence. Thank you.
Oh yeah, any questions from Joe?
Yep.
So, you're planning on funding this through government grants, yes?
Yep.
And you made a comment that you're going to achieve or anticipate financial profitability within approximately a year, is that correct?
Yeah, at the beginning of 2022.
Okay, cool. If you're not successful with government grants, just because my experience with government grants are not always terribly reliable,
Yep.
have you considered any alternative sources of funding?
Yeah, basically we don't actually need that much to get started because the components aren't actually that expensive, which means the profit margins are higher. And so we're going to use that to potentially attract an investor, because initially we only need like $10,000 to get started, and that's pocket change to most people with money.
Have you considered a group of people that you would be approaching? Because I noticed the industry sector that you mentioned was gaming. Have you considered defence or any other industry sectors?
At the moment, we're mainly focusing on gaming as an alternative and mainly wheelchairs and accessibility as a market.
Okay,
and so
excellent.
we'll be approaching them first.
Great, thank you.
Does anyone else? Okay.
Tested your system?
At the moment, we haven't officially tested it with someone who has a disability, but we have been testing it with other people who don't have disabilities, and we've got someone who has a disability lined up and happy to test it.
Do you want to just run us through what you've tested?
Okay, we've basically been testing the calibration and the control system. So basically, once you turn on, you've got a couple lights that flash and symbolize that you're supposed to stay in one spot in a comfortable position before it starts. And then once it starts, we've got the system where it has bone conduction audio, which actually tells you what's actually happening. So it'll say calibrated, and you'll get a light that flashes, and then they can tilt their head and it'll move around. And we've sort of got that working in one of our videos, which we had prior, but we went through that quite quickly.
What other designs did you think about? You showed your competitors up there, and obviously there's quite a lot of breadth type devices. What other kind of prototypes did you look at?
One of the major ones that we did look at was the one that the late Stephen Hawking used, which was basically an IR sensor on the cheek, which he used quite effectively, and that requires very little control. And so that would be definitely an advantage for our market, but we determined from our surveys that head tilting was the most suitable for the people that we surveyed.
I think to just expand on that, so we actually did try a few other methods as well. So instead of just using accelerometers, we tried using what is known as ECG, so electrocardiograms, using brains to control, which sounds really cool. The problem is they're quite expensive, which was way out of our budget, and also we did talk to a few people who are in the field, from the union, from the hospitals and things like that. And they mentioned that while it is possible, it's still a very new emerging field. So this is something that requires years of research, and it's definitely not doable in the scope of maker games.
Yeah, and just adding on to that, some of the clients mentioned that for the ECG to work, it has to be on your head, like on your skin. So you'd have to shave your head, and as an aesthetic thing, most clients didn't want to do that. So, yeah.
Thank you guys for the presentation.
Brilliant. Thank you.
Thanks.
Poverty, gender inequality, and inaccessible energy are all major issues that developing countries are still trying to eradicate to this day. Good afternoon, we are Team Himawari, and we have been engaged to create a sellers app to help optimize the sellers experience for a Suriyamuki. All the way? My bad. My name is Profeta, and joining me today is May, who will be exploring the app features and evaluation, as well as Calvin, who will be walking you through the demonstration of our app. Right, so, yeah, Pollinate's mission is all about empowering women as leaders of change, also known as Surimukis, to help distribute products to the world's most neglected communities, products of which include solar lights and gas cook stoves. Now, I want you guys to meet Ladley. Ladley stopped studying in Year 10 due to financial difficulties and was no longer able to pursue her dream of becoming a beautician. After becoming a Surumukhi to help overcome those obstacles, she has faced challenges such as remembering how much customers owe, as well as understanding her general sales performance. And this is largely due to the fact that she has not been given a way to record sales transactions. Now, this leads us to define the problem of our project. How can we empower Surumukhis so that we can provide them with an easy and intuitive way to help keep track of sales performance?
And to answer that question, we created the point of sale app, an end-to-end point of sale app. And here you can see the high-level app design features that are designed with the user specifically in mind. So this app was designed for the illiterate, and we have two design principles that we stick to, which is linear navigation, which is reducing the hierarchy of information, and skeuomorphism, which is to mimic reality as much as possible. So this app is a simple but all-in-one app, and currently it features Salesforce integration, inventory management, and data analytics, and in the future it will expand to payment integration, speech-to-text, and geolocation. We have also conducted a user acceptance survey to get feedback on how people use the app. And now I'll pass it on to Calvin to demonstrate it.
Unfortunately, we don't have video demonstration. However, I have it on my laptop, so is it okay if I just show it to one of you, like a demonstration about how our app works? I'll just show it. Yeah, so sorry about that. So basically, for our app, it's just we try to get it at the style of like a simple e-commerce website to make it really easy for Surumukhis to navigate around. So here's just a standard login page. Although this is a demonstration, we'll focus more on functionalities rather than aesthetics. For the final product, we'll be working more towards making it look like a really simple design, implementing features as they describe the speech-to-text functionalities and geolocation. So what I'll demonstrate to you is like a simple point-of-sale action. So basically, as a Surumukhi, what you can do is you can add items, often by color name, to add to the Surumukhi's inventory to later sell to the customers. For example, I'll just add this, in this case, a mosquito net, where I just point it, add it to the inventory, and we'll see that, well, in this case, sorry for the inconvenience again, you see that it's added to the stock. I already have, in this case, the Surumukhi already had these items, which they can just navigate through and select how much they would want, just like you would on eBay or any other site, and select the customer to make the sale.
Do you want to show the others as well?
Standard login screen, as I explained to you earlier, and just a simple point of sale action where you add items from the inventory, put them into the Surumukhi's inventory, and later sell to customers, which we keep a track record of thanks to Salesforce. We try to emphasize the idea of having some sort of data visualization tool where we can demonstrate the performances a Surumukhis has made in the past, making it a really simplistic design or easier for illiterate individuals to understand. And yeah, thank you. This concludes our presentation. But with our simple yet elegant design, Surumukhis like Ladley can pursue her, make enough money and pursue her beautician dream. Thank you.
Can you clarify the problem that you're trying to solve? I must have missed that a bit, sorry.
Yeah, sorry we didn't make it clear enough. But Pollinate is basically an organization that they go to like disadvantaged communities and give products to women entrepreneurs so that they can sell it to their local communities. And this is a bit more advantageous than just directly giving and donating products to these communities. They build the economy, build entrepreneurs, build gender equality in these communities, tackling an array of issues. And our job specifically is to create an app to really streamline those sales so that they can perform better in the long term. Because right now, I think their method is quite rudimentary, maybe just memorizing sales at the top of their head, and they're not being efficient with their performance.
Thank you. And what communities are you targeting? Is this in Australia? Is this what we're talking about? Or
Sorry, what are we targeting?
what communities? Whereabouts is this program happening?
Right, so Pollinate Group has a customer base in India and Nepal. And basically, the entrepreneurs, they're all targeting like rural communities. And because all of these products that they offer are like solar lamps and stoves that are for communities, we find it hard to access to electricity. And it is a way of empowering people who are living in poverty.
Can you tell us a little bit about any kind of competitors, including just alternatives to what you proposed, or any kinds of obstacles to people adopting your product?
Yep, so there are currently point of sale apps in the market. They're targeting this specific community as well, but we've been approached by Pollinate to create one, simply because the price point is too high, and also they price it for monthly basis, or sorry, the subscription basis is not really suitable to the time frame that the Suryamukis use it, because they don't use it every month, but rather in like a few months here and there. And that's why they approach us to create this app.
Are there any last questions from judges? Thank you very much.
Thank you.
So, good morning, everyone. Welcome to the final showcase of the Team CoSnap. And this is our team: Aya, Wanti, Babita, Megan, Chantal, and me. So our team is a group of multidisciplinary engineering students. And on the left-hand side, you can see Dr. Mr. Harley, our industry mentor and supervisor, also the founder of CoSnap. And now I would like to ask everyone a question. How many of you sitting in the audience today enjoy spending a whole day out on the beach, playing with the sand or running across the shore? Well, how will you feel if I told you that our beaches are in grave danger, and the things I mentioned could since exist?
Severe storms have risked damage to a whopping 39,000 Australian beachside properties. A study has found that around 50% of our country's entire sandy shorelines could be threatened in under 80 years. However, this isn't simply a local threat. Globally, it is estimated that 1/3 of the world's sandy beaches could disappear in as little as 30 years. This is where our CoSnap team comes into action. CoSnap is a global citizen science project that aims to capture and monitor our changing coastlines. This is especially important to devise a plan in the future to protect our at-risk beaches. So how does CoSnap work? Members of the general public use the fixed CoSnap cradles that are available on the beaches to take photos of the beach. These photos are then posted onto social media. It's as simple as that.
As you can see, our competition here is the fixed post cradle. These cradles are mounted on the ground and cannot be moved from one place to another. It is evident that an educational and more portable solution is much needed. Therefore, we created CoSNAP's very own portable do-it-yourself toolkit with an aim to engage the school group and rural communities with coastal monitoring. So here's our solution, a fun, lightweight, interactive do-it-yourself toolkit. Since this toolkit is 3D printed, it is very easy to manufacture and assemble. This gives an opportunity for the local community to manufacture this design by themselves and get introduced themselves to the world of technology through 3D printing. Now, let me demonstrate how this design works. First of all, mount the Gorilla tripod on the fence. After that, level the bubble. After leveling the bubble, place the phone in the cradle. Maintain the angle and rotation in a way that a reference point and lots of area is visible. After that, click the photo. After taking the photo, take the measurement of angle from the inclinometer on the side and measurement of angle from the rotational joint. Finally, upload the image by using a site-specific hashtag through social media or by using our revolutionary CoSNAP application. But wait, there's more to the show. Our team has also created its very own automation software, and Mihui is coming to speak more about it.
Okay. So currently, the CoSNAP industry has to manually download the coastal images that are uploaded onto Instagram and Twitter. So this is a repetitive and time-consuming process that takes hours of their time, and they could have been used this time to do more important things. Therefore, our team has created a Python program that is able to automatically download all the images from the Instagram and Twitter. So simply run the code and sit back, just enjoy and do the work for you. So how simple is that? Yeah. And this software is also able to sort these images and retrieve the most important data. For example, the username, URL link, posting time of each post, and store them in an organized CSV file.
Saving our beaches is now going global, with CoSNAP being rolled out throughout the world, such as in India and Brazil. By investing in us, you are investing in your own future. We ask that you help us protect our beaches. Thank you.
Sure. Okay, well done, guys. So you said that you were targeting school groups and rural communities. Did you sort of speak to anybody about perhaps their access to 3D printers? Is the idea that you print it locally? Is that?
This should be something that is already printed. However, we have given the option that if a school that has access to 3D printers wishes to print their own, they have the options. All the files are ready and available for them to use.
Okay, why did you choose to focus on those two groups?
Because CoSNAP, no, it's not only focusing on these two groups, but like school groups and rural communities, they need to be educated and like given and raising awareness about coastal monitoring and the importance of coastal monitoring to protect our beaches.
Sure, thank you. Can I ask about the software? So what's the the code that you built then? What's the input and what's the output? And how do you tag items? Is it recognizing the same beach, or do you have some method for tagging them?
Okay, actually, we use the Python to develop the software, and we use the Selenium library in Python.
So we just simulate the browser to access the web page, to simulate the human operations, to input input searching words and to find the page we wanted, either on the Instagram or either on the Twitter, and just call the information we needed.
CoSnap already has their own MATLAB software that sorts these images. However, this code is just for like saving time, so the user doesn't have to manually download each photo from Instagram, and it's a time-consuming process.
Of all these images, at what point is somebody or AI going through it and deciding, okay, I've noticed that there's a change in this particular beach? Is that your company that's doing that, or are you thinking of another company that will be taking your information and doing that process?
Okay. So our company CoSnap already does that through the MATLAB software it runs. So it's able to find fixed points in the photos of the beach to determine if the photo taken is a good option, and then it runs it through the software and it analyzes a line of the shore, the coastline.
Okay, and to observe how it's changed over time, who's doing that?
The CoSnap founders, and the software does the work.
Okay, thank you.
Do you have any competitor doing the same job? Do you have any competitor doing the same job?
Yes, there are competitors doing the same job. However, this has been done for CoSnap, and it is customized to Instagram and Twitter because CoSnap uses hashtags, and this is specific to the company, and we have developed a software that just does that. And it's also, most of the other softwares, you need to pay to use them.
Thank you very much.
Hello. Okay. Hello everyone. Welcome to our Bluetooth headset team. Unfortunately, our group was not very successful in building a working prototype. So here we just show our proposed work and our proposed scheme and the work we have already done. So the challenge is to build an interphone system using Bluetooth devices. So we want our product to meet those technical specifications. So we want to have 5 to 8 devices in the group, easy pairing and stable connection, supporting a larger range, and has better battery life, and it should be of lightweight and with small time delay. So our group has 6 members from different majors, including telecommunications engineering, electrical engineering, and mechanical engineering. So our solution in proposal includes using CSR 8675 Bluetooth chips. So we want to use 3D printing to produce the outer case, and the basic topology is to use a bidirectional chain for the PicoNet. And we designed the layout for the PCB, the printed circuit board. So the inner structure, we chose to use 8675 Bluetooth chip, and we built our the development board. And our prototype was not very successful because there are a lot of limitations using Bluetooth devices. So it is far beyond our level to program the chip properly. And in the market, most of the chips can only support pairing 2 peer devices. So that means the topology can only is limited to the bidirectional chain. So it is very hard to add more devices to the PicoNet. Racing will be presenting something on the PCB and the auto case.
Hello. Okay. So this is our development board, and we have our Bluetooth chip module here. So we use this to test our firmware, but unfortunately we can't do much about the coding. We don't have computer students here to help. So we do some configuration modification for the existing sample firmware provided by Qualcomm, the chip manufacturer. And we pack this, all these ports, all these chips, other say, audio amplifiers things to our PCB here. So this is the actual size of the device we want our referees to have in hand. But due to some design issues, this is not working currently. And we can fix this with some time, but we won't be able to achieve what we want due to the software issue. This is the case we did for this PCB. We didn't have that now because the member who have this didn't make it today. But this will fit into that case, and that's the prototype we have right now. So currently we have some serious software issue, so we are not able to finish or complete a working prototype right now. Also, we think Bluetooth is not the ideal technology for this challenge. We've heard the other two teams are using different technologies such as Wi-Fi and RF, so I hope they can have a better prototype come out. Thank you.
So can I just ask, you said that you showed at the beginning the slide that had kind of what you were wanting to include in your solution, but what was the problem that you were given from the company?
So the company is Ignite Refereeing. Their referee, they provide referees to football matches. So they want the referees to communicate with each other. So they have a communication device here. And the current product can only provide 4 devices in connection. So they want more than that. That's why they want a new product.
Are you able to give us just some idea of which parts of your solution you did get working? Did you maybe do some simulations or do some unit testing and you had part of it functioning? Do you want to just briefly let us know about what you got working?
So right now we managed to have only one audio channel. Like for these 2 boards, one board can transmit audio stream to another. That's all we can do right now.
Since that you know that Bluetooth is not the ideal solution for this, do you think if you had chosen the other 2 options, would you have achieved better, in terms of addressing the problem?
So he's a telecommunication student, so he thinks, say, if you use RF, it would be easy to have something working. But with this, the coding part is too hard for us. That's the problem. So
At the very beginning, we chose to use microcontrollers plus Bluetooth module, which is called HM10. But that was not, we found it very hard to build the audio link between the devices. Then we chose to use Bluetooth audio modules. But those modules are very hard to program. And so we contacted some professional engineers, but they say it's not very realistic to have more than 4 devices in the group.
The reason we chose this is when we saw the specifications on the chip, it's very promising. Like we can really see it's working, but it's not at the end, unfortunately.
I really liked your reflection slide. How are you working with your company, with your industry partner, to solve these problems that you've encountered?
The company provided us with the current product, and the company got that from a company in Shenzhen, China, and it's the current solution for the challenge, but it does the product cannot support the specifications given. So it just we were just given the current technology, but we don't know how it works. So we need to learn by ourselves from the beginning.
Thank you.
All right, thank you very much. Big round of applause.
Hello everyone, I'm Michael, this is Vanessa, Alan, Julianne, and we are PMT. We're a team of multidisciplinary students from computer science, engineering, and finance. Welcome to our pitch for social finance, a communal goal approach. What is social finance, you might ask? Well, Tim here has the same question. He has a stable income, full-time employed, and small savings. However, he also has long-term financial goals, such as home ownership, cars, family, early retirement. He knows that a 0.5% interest savings account just won't cut it. His friends talk about stock trading, but he didn't study commerce. Where does he start? Which tools are best? Well, Tim is not alone. 60% of Australians are financially illiterate. 35% stated that dealing with money is often stressful or overwhelming. The current fintech market has many instruments for personal finance. However, information barriers exist. A novice lacking in financial knowledge might not have the confidence to invest and therefore be demotivated to achieve financial goals. So what is Tim to do?
So we found that 75% of our surveyed users currently get their financial knowledge by learning from their peers, and we've also found that a little less than half of our surveyed users learn from reading financial news and also browsing online communities such as Facebook groups, Reddit threads, and Quora as well. So currently there's no single platform for users to learn, invest, and discuss about personal finance. We have tools such as eToro and ComSec, but they're mainly only for trading, and people have to seek elsewhere if they want to learn about the fundamentals of personal finance, such as savings, super funds, and home loans. So our industry partner, Perla, has identified this market gap and come up with a product that not only allows trading, but also encourages collaboration and learning about all aspects of personal finance. So, however, we can further help Perla differentiate from its competitors by introducing social features to improve platform engagement and user loyalty.
So our solution capitalizes on these market opportunities, utilizing the online communal aspect of social media, so that users are able to, so it actually generates interest for users to complete their financial goals. Users are able to learn personal finance basics, create shareable goal templates, share accomplishments, and also work together as a guild to complete larger financial goals such as quests, or known as quests. So how was Tim able to use the platform? So Tim has heard about stock trading from his friends, but was never sure on how to start. So he's been looking around for advice online and has found Perla. So on Perla, there's since Tim wants to learn about stock trading, he joins the stock trading guild. So within the stock trading guild, there's a feed page. Within the feed page, Tim's able to view a variety of discussions, posts, and questions so that he can join in and ask for how to get started with stock trading. And so there's also a goals page. This is where there's a variety of goal templates in which users like Tim are able to copy them into the portfolio. And it also provides a great way for Tim to get started with his stock trading. So finally, this is the guild quest, which is accessed from the quest tab. An example is shown here, where all members try to complete this quest by having a combined total of 100 stocks in the portfolio. So let's say in the future that Tim wants to log this progress and has acquired 17 stocks. So once he's logged this into the quest, his name is now on the leaderboard, and due to his contribution, the first milestone is completed, as denoted by the golden star.
All these features were built on React, using the React.js framework. So we can easily scale this by adding more features with funding and collaborations with financial entities. So our user-driven design integrated with banking, super funds, trading, we are able to create the one place for all financial needs. We have received positive feedback from academic and industry experts, as well as peers who have given us constructive feedback in order to ensure that our platform is accessible and intuitive for all users. Overall, our goal is, what we are doing is creating a communal goal social financing, where users in the platform are able to gain confidence in achieving their financial goals and their milestones in life. So help us, help Tim, help all Australians to learn, share, and achieve financial goals together. Thank you.
Any questions?
Okay, so based on your user story, where is this person finding out the knowledge to know then what their quest should be?
Well, because they're part of the stock trading community, the first natural thing they would see is the feed, right, which has the discussion happening. They can either choose to learn from the discussions or ask questions on the forum, right? Because it's an open feed. You can just post the questions. How much of the stock should I invest in TESSA? Such questions. And helpful members such as Alan can direct him to a goal that he might have created on the goal feed for the guild, specifically for stocks and how much to invest if you're achieving certain sort of goal, present value or such a goal value at the end of your investment timeline. Right.
Okay, so just so I double check correctly, you guys have created both the feed and the quest for Perla?
Yes. Oh, yeah, they have to implement it.
Yeah, but those are the two. Okay, great.
Yeah.
Based on your problem that you're solving, you connecting people in the community for addressing this issue. Is there any point that Perla is going to have a sort of like a sanity check to make sure that the information being spread is actually accurate or close to accurate?
Yep, they have. We were trying to implement profiles as well for Perla. That will allow users to add trustworthiness, like stars, to trustworthy users. For instance, if they have academic background or if they're in the industry, and you'll be able to view this on their pop-up page. And so, for instance, if you're to hover on one of their usernames, you'll be able to see a small pop-up that says trusted user. Here are their accomplishments, so what. That will give them a bit of trustworthiness as well. And because they're part of the community, right, people with more trustworthiness gain more notoriety. They get more followers, for example, and users are able to trust what they're saying. And their portfolios are all available to see on Perla. You can see how successful they are. And once this is integrated into the platform, everything will be very easily accessible.
Can I ask about the community? I mean, a lot of this software innovations depend on building a massive user community. Do you have any plans for how you're going to build the community and how easily could be copied by someone else who could maybe overtake it?
Currently, Perla has a bunch of fintech influencers, which allow for them to influence other people to join Perla. So that would be a good way to generate users. And the fact that we also have like this feed is also another way to generate more growth for users as they recommend, let's join this guild, and then it will just like incrementally increase the user base.
And also, when we directly collaborate with banks and super funds as well, we have like direct affiliate links with them as well. So because there's also the direct association with the banks and established companies, that will give us a bit more credibility, and hence people will want to choose our platform over other platforms that don't have as much credibility.
All right, thank you very much. Let's give it up. I would now like to invite Rubock up to the stage, please.
You all ready, guys? In January this year, in a small rural town in Tasmania, a miner left for work and he didn't come home again. It took several weeks and failed attempts to retrieve his body. Unfortunately, accidents like these are woefully common in the global mining workplace. It's up to us as tomorrow's engineers to develop safety technologies that can save countless lives and modernize one of society's most crucial industries. By 2025, the Global Economic Forum expects that over 1,000 deaths and 44,000 mining workplace injuries can be prevented via digital transformations, such as IoT sensors and trackers. IoT sensors alone are expected to add up to $34 billion of value to the global mining industry by this time frame.
This has inspired our mission to develop a low-cost system that enables the efficient and safe organization of personnel and assets in underground mines using existing Wi-Fi infrastructure. This has been the core of our challenge, to balance functionality and user needs while maintaining low manufacturing costs in a workspace that doesn't have GPS available. This has primarily been an optimization problem that has required innovative design and cutting-edge technology. Early designs by our existing competitors are high cost, high maintenance, and often require additional infrastructure that can be at a cost that can make it prohibitive to invest. Mobilaris, Redpine, and Digital Matter have devices that priced between $150 and $250, and also include up to tens of thousands of dollars worth of additional infrastructure. Our design, when projected for a production of 500 units, is expected to have a production and material cost of $17. This is a key component of our competitive advantage, being able to offer a device that is at a fraction of the cost of our competitors while still achieving the same core functionality through our innovative tag-to-tag network.
Like mentioned, our competitors' high costs are due to the additional Wi-Fi, Bluetooth, or RFID infrastructure that is required to achieve live position tracking. We, on the other hand, have made the wrist tags the infrastructure themselves. By using a partial mesh network, each tag is able to act as a beacon to other tags, and in this way, this creates a dynamic chain so that miners who are outside of the static network range are still able to relay and receive information from the central server. And so through multiple iterations of prototypes, we've managed to create a wrist tracker that is lightweight, small, and will meet IP67 dustproof and waterproofing standards. Despite its small size, we've managed to include a Wi-Fi module, an accelerometer, and a 350 milliamp battery, which can last up to 28 hours, depending on the level of user movement. On the user's end, we've also managed to include an RGB LED to act as an emergency indicator, an on-off switch, which also doubles as an emergency call button, all of this which is achieved on this tiny PCB over here. When not in use, simply clip and charge the device and it will be ready for the next day.
Our Python-based server connects to all of the tags, which are each given a unique identification number. By sending user movement and Wi-Fi signal strength data to the server, we can provide a position estimate. Our fingerprinting tests indicate very promising results, showing that even weak Wi-Fi signals in small enclosed spaces can still provide useful position data. Using this data, resource and labor flow can be optimized. Our device provides a key piece of the puzzle that is essential for providing worker safety and productivity optimization. Using data fusion techniques, we can improve the accuracy of our position estimates, even when very few Wi-Fi static networks are available. Customers that have already purchased expensive positioning software can still use our tags inside their system, as we have designed an easy-to-use API and data extraction system that can be interfaced with existing commercial software.
Our unique approach and solution has attracted significant interest from the 2020 MindSafe International Conference, where OH&S managers from world-class gold producers like Northern Star have expressed an interest in our design. As a part of the Rubock Deep IoT project, we're looking for new customers and partners to join us in this mine safety revolution and make the mining environment a safer and more productive place for all. Thank you so much for listening to us. Any questions?
I have a question about fail-safes. How are people going to know if the battery's low or the communications are so low as not to be usable? How do you ensure that people who are depending on this are not let down?
Right, thank you very much. So there's another small LED inside the device that indicates that the device is turned on. Additionally, if a device goes missing from the server, people on the control end can notify supervisors and managers within the mine so that the device can be repaired or replaced.
And I've also mentioned there's an RGB LED in there, so the different colors that we'll be using would signify what mode it's currently in.
Yes, so I'm interested in, you talked about the accuracy, but how accurate is it? And how is that accuracy impacted, say, and I'm not sure what happened in Tasmania earlier in the year, but say by a cave-in or something like that? And why a watch? Why a wrist?
Right. So there are 4 key modes of operation of the device that purely depends on the available infrastructure of the client. So the most common case is where we will have at least 3 static Wi-Fi networks in range of the user. So this allows us to perform a multilateration approach, which gives us an accuracy of roughly 2 meters, depending again on how close the sensors are. We then have an operation mode of a 1D measurement, where say we have 2 static networks at each ends of a long tunnel, and then we can estimate where the user is within that tunnel. We can also use the partial mesh technology to give people an estimate of where they are, even if they're outside of static network range completely, by relaying the information through each device along the chain. So in terms of why we chose a wrist tag, well, it needs to be a comfortable device that's easy to use, and it also gives us another really important piece of data, because our device has an IMU, an inertial measurement unit, on the inside. And this allows us to track the user's walking. It gives us acceleration and gyroscopic values, which we can then use to estimate, the person's moving very fast. We should increase the rate at which we do our polling events. So yeah, that is the key reasons for our design choices.
There's also other options like having a device like a phone or something, a communication device, or putting on a radio, putting on a helmet. But having it on a wrist is very convenient. It's always there. You don't have to pull it out or anything. For emergency reasons, there's just an easy button press. And it also has the option of future advancements, like expanding the market that we fit in. So having more watch-like functions, so telling the time, and some sort of LED screen that sort of gives some more information than just the on-off sort of feature.
May I ask if you have spoken to a miner?
Yeah.
Have you had that opportunity?
So earlier we presented our current prototype at the MindSafe International Digital Conference. So then we got an opportunity to talk with a variety of different companies and stakeholders at the event, including some representatives from the Occupation Health and Safety Management team at Northern Star. And so our device quite well fits in with the current scheme of things, with the key difference being that it's up to an order of magnitude cheaper than existing devices out there. One key quote from a previous affiliate of ours, UNPAN, is that there's only so many places you can go underground. And so quite often using an RFID system that is extremely expensive with high maintenance is going to give you the same level of distance measurement as our devices will.
So with your competitors, why are you so much cheaper?
A lot of our competitors are deciding to mark up their technology, as it is a very emerging field and people are very desperate to grab this because it provides such a safety advantage. Another key reason is that the partial mesh network of our device allows us not to use individual Wi-Fi beacons or Bluetooth beacons. So these beacons are a very large part of the problem. You're required to set them up all around the mine. They require high maintenance. You need to set up the power distribution for them. And then, of course, you have to interface them to work with your tags in the system. However, using just our individual tags as the beacons themselves, we can cut down on all those costs. So now all the user needs to do is have their central server hooked up to each of these tags, and it'll do all of that work for them.
Also, could you take off your tag? So you asked us if we spoke to some miners. Well, we did consider some of the things that they might be concerned about when actually using this device. So as you can see here, it's quite small. It's not very unwieldy. It's about like the same size as like a GPS tracker, like a Garmin GPS tracker. Here's one for reference. And one thing that we did add that adds to the sort of safety is we added these FastX clips to the end. So if it ever gets caught on something for an emergency, they can just quickly unclip it and then escape.
Great, thank you.
All right, thank you very much, Rubock. Now I'd like to invite Ignite Referee Assistant Team 1 to the stage.
Testing. Soccer, or you like to call football, is played all around the world. I don't know about you guys, but during the FIFA World Cup, I used to wake up at 2 a.m. to watch the match. And now there's EPL, EuroLeague, and even the A-League that a lot of people around the world are staying up to watch the games. Professional football matches have at least about 5 referees on court or on the field at all times. However, that's not so true for amateur referees. I had the luxury to go watch an amateur referee match over the course of the project. And I think it was Macquarie University versus another university. And the referee that turned up was about in his late 40s, maybe 50s. And there was one referee. He was a lot slower than most of the players. So throughout the matches, he would basically estimate or guess on whether the ball is in or out of the field on players' reactions. So moving on, referees cop a lot of abuse because of that. Basically, as you can see on the images, they get yelled at, and I play football myself, and I also yelled at a ref. Basically, these are our motivations, and as you can see, the VARs, they have at least extra 5 players in the computer room to watch the replays. These are problem statements. You could go through them on your own time if you have the slides. Okay, so the slides are the wrong slides throughout, but however, we have live demos that we have prepared for the judges. Basically, to solve our issues, we have a tripod and a camera attached to it. This camera will be able to detect whether the ball is in or out of the field, and in our final product, there is 8 cameras around the field. For this demonstration, we have used one to demonstrate whether it's out of the field and can even detect when the ball is in the goal line. For referees to access these camera feeds, all they have to do is log on to a local server set up by our other Raspberry Pi, and they will be able to get notified when the ball is in or out of the field. In our final product, we will have a wrist guard that attaches onto their arm. Without further ado, I will pass Ivan on to the demonstrations for the judges.
Yeah, sorry about that. The audience won't be able to see, but the judges will be able to see just fine. So for our demonstration, the 2 red markers will be the goalpost for a soccer match. And I'll be demonstrating a soccer ball because my mom always told me not to kick a soccer ball inside the house. So if Brian could set up. Here you go. Yep. So for setting up our model, all we got to do is just select 3 points to make a triangle. So for Brian over there, we'll be selecting our goalpost and the penalty marker, that's it. And then all it will do is just simulate the real coordinates into a virtual coordinate that will be showing up as a virtual field. Now, it will detect out of bounds and if it enter the goal lines. So for me right now, if I enter out of bounds, your phone, sorry, Brian has not handed out the phones yet. So all the referees have to do now is just connect to the website and start listening to the match. Once they start it, if I step outside of the field, the referees will get a message and a timestamp signaling that the ball is now out of bounds or inbounds. It won't keep detecting unless the ball is back in play. And if I now step out of bounds, there will be a timestamp and a vibration that will signal the referee to look at it. So, yeah. So there will be a vibration, and it won't occur again until the ball is back in play. Now I step over the outside line, it should vibrate again. Now, let's say if a referee did not see the goal and our pies detected again. So if that did not happen, the referees won't know, but the players are saying it was a goal, and the pies are messaging him, telling him it was a goal as well. The referees will be able to access the pie and watch a replay of the event occurring. This can happen for all events, if it's out of bounds, if it's goal, and right now Brian will walk around and show you the replay. For our pies, their main reason is just to support the referees' calls. They're not there to make decisions for the referees. The referees are the ones that will make the calls depending on his experience and the messages received by the pies. And if the referee sees a foul or anything that occurred that the referee couldn't have known if that had happened and the players are arguing again, they can simply enter through their phones and request a replay. I'd like to invite one of the judges to actually try this. So if you go into the phone, there will be a tab. Tap the replay tab. And then simply press Raspberry Pi 4. Yeah. So yeah, currently only one phone will work at a time because our Pis cannot queue up multiple footages. And then this way, the referees can simply go back to the replay and watch if this had occurred. And with the 8 cameras, they'll be able to view from different angles, from different Pis, with each Pi with a unique naming system. In the future, this way, the referees can pick what videos to send out to the audience and the crowd. They will be able to simply connect to the local Pi server and see the display messages with the timestamps, and then simply look at the replays to see if the referee. And the referees will get to decide what videos they get to see. This way it will calm the crowd down. They can even show it to the players. It will calm the players down and enforce the referee's decisions. Now, I'd like to thank you all for being here. I'd like to thank Alex Long, especially, for helping us getting this prototype working. And thank you, Kevin, for Maker Games. Yep, thank you. Any questions from judges?
Neural network model, do you need to train it separately for different fields and different player uniforms?
No, a simple grass field works fine. If we could show the demonstration, it will show that. But right now, we can just train it, keep training it to make the model more accurate. But any grass field will work fine.
So you've trained it on one field and tested on another?
Yep. We can even show it up in here. It doesn't even need to be grass field. It can detect the ball and people fine.
If you walk over here, you can see that it's detecting people right now. So it generally will work in any field that you mentioned.
Even indoor courts.
Yeah, so basically any field will work.
So does the ref take the infrastructure and set it up themselves with the 3 points? Is it inbuilt into the field?
Yeah, sorry. Currently, the refs will have to do it manually. And currently, they will have to do it through the website, but that's for future work.
How much do you see it costing?
The whole 8 cameras will cost around $5,000, which is less than what we stated in the problem statement for 10,000.
Because other competitors, we know at France, there's a competitor that sort of does this similar thing. Each of their camera for one camera costs about $10,000. And others basically put in stuff into the ball, such as a little tracker and all that. They're not players, and some players will refuse to wear that.
And compared to VAR, that's commercially available right now, they will have to run off the field and watch the replay. Whereas our system, they can watch it straight on their wristband.
Have you approached any sports teams and done any sort of testing here?
Currently, no, because no team will want to have cameras around the pitch right now. And Alex is actually trying to sort that out. And we even have people from Europe looking in to try to see if our demonstration works fine.
Just unfortunately, due to COVID and all the soccer matches having closed down, and when we got this working, there wasn't any local matches that Alex was able to set us up, so we weren't able to test this.
Any other questions?
Are you dependent on any third-party software?
Sorry?
Are you dependent on any third-party software?
No. To set this up, we did use a free app called VNC Viewer, but that's just to set this up currently, and it's free to use it all.
Awesome. Thanks a lot, guys. Appreciate it.
Thank you.
Good afternoon, everyone. We're CrossFit Team 1. Does everyone know that thousands of people doesn't have any access to prosthetic devices? There is 40 million amputees in the underdeveloping world, and only 1 out of 20 of them have any access to these devices. One of the major reasons will be the cost. It is estimated that one device would be around 6 times of the annual income of the state areas. Therefore, our objective is pretty much helping all of these people around in this area, which is the underdeveloped countries. Our solution is the parallel bars with the limb capture stand functionality, and we hope that this device will help people in the would help people in the area that is the electricity is scarce and the infrastructure is unreliable to be developed. Therefore, we are going to present you our devices.
So here's a final solution for the parallel bars. As it can be observed, on one end we have the handles, and on the other end we have the wheels to make the design portable enough, which is not offered by any of the products available on the market at the moment. So this design can be foldable. This is foldable and compatible and can be set up with the minimal effort from the user within minutes. And this has majorly 5 components, which are the 4 bars and the bottom frame. Currently, for the prototype, the plastic pipes or PVC pipes are used, but for the final proposed design, it was made sure that aluminum pipes are used to satisfy the stiffness requirements for the design.
As you can see, it's very easy to height adjust this, and it's a mechanical design. It can be set up real quick, and there's no technical background needed whatsoever. And the design is very stable, and
yeah, and here's our solution for the limb capture stand. So I'll first be demonstrating the transfemoral limb capture stand. As you can see, the vices around the ring are adjustable. So when this is pressed against the leg, it will exert a pressure simulating an actual leg in a prosthetic socket, and it will give us better fitting. And let's see. Yeah. For the transtibial part, we used a elastic material to simulate, as well as a total surface bearing scenario for a lower limb socket. Yeah, and both of them are height adjustable. So now for a live demonstration. Yep. And normally 3D printing would be done at this stage. Yep. And release.
Okay. None of the existing solutions have ever combined transtibial and transfemoral limb capture stands and integrates them into a parallel bar attachable apparatus. The 3 pieces of clamp plates and clamps allow size adjustable features, and the whole equipment is lightweight and foldable to fit limited space in mobile clinic. So while our primary revenue is from directly selling or renting equipment to thousands of mobile clinics in remote areas, particularly for those without access to electricity in Africa, we also want to expand our business to global medical equipment distributors such as Rubock and OPC Health. Our channels to market are partnerships with rehabilitation centers, non-for-profit organizations, and local health authority to deliver affordable solutions. We also want to advertise our service on social media and continue existing partnership with Pendlepoint, a mobile clinic distributor, to expand our business in more rural medical facilities. Our team represents the diverse and inclusive nature we want to achieve in the future of prosthetics in developing countries. Thank you for your time, and the team is now open to any questions.
What is the problem that you're actually needing to solve?
It's not, these equipment are expensive, and it's not easy to take this equipment to these rural areas where people need them. Which is why we made a mobile solution, so that even one person can just lift it, put it in the back of a pickup truck or a van, and where the van goes, the clinic is ready to set up.
So can I ask who is going to make these? And what are the requirements of it? You know, what kind of load-bearing capacity does it have to have, and so on?
So as per the client requirement, we have used commercially available components. We also suggested the manufacturer who can provide this. They can be, the whole design can be welded together since it's made of metal, the final design. And any manufacturer or supplier can make it all together.
Okay, so is there some sort of quality requirement to make sure you don't get someone making something all right?
We did test this in FEA simulation, and it can easily take loads up to 150 kilograms. And with a factor of safety of 2. So even if someone extremely overweight, or 2 or 3 people walk on it, it will still be fine.
So for the link capture stand, for the actual product, not this prototype, for the actual product, the link capture stand for transfemoral and transtibial should be able to hold half of the body weight, which would be 70 kilos.
So did you test it? I'm guessing there. You probably know
not
people
for
about
the
that,
prototype, yeah. Not for this one.
Are there any other questions from the judges?
Yeah, sorry, just quickly, with the actual product, so you're trying to target people who don't have access to having prosthetics fitted, is that?
Rehabilitation access. As well as fitting. Yeah, and fitting. So once someone puts the leg inside these rings, it will be basically 3D scan, so that it can be sent for manufacturing.
And how does the length of that bench that you've built, how does that compare to what currently is available used in rehabilitation clinics?
The current one's around 3 meters, ours is 2 meters long. So
And
yeah, this is easy around like 5 or 6 steps. So that's more than enough for a person to get to the side, turn around, and come back.
And you mentioned that you'll be replacing the PVC with aluminium.
Yes.
And did you say that you were targeting not just rural areas, but places in Africa?
I said it's a rural area with limited access to electricity because this is a fully mechanical apparatus. But most of the parallel bars on the market are electrical and very expensive, like thousands of dollars. Yeah.
Other power bars are completely screwed into the ground, and they don't move at all.
Thanks.
Thank you very much. I would now like to invite Fellow 2.
Good afternoon, everyone. This is Pillar Team 2. The technology we use in the finance market changed rapidly over the past 200 years. With history trading stock with a stock certificate, telephone, and computers, we're now able to buy and sell stock in real time with a click on our mobile phone. The way we communicate also changed. We no longer need to meet our friends in person or send a letter to our family living in another city. We now have the internet that allows us to communicate and share information with everyone around the globe. But the way we share our personal information didn't change with the invention of internet. We still talk to our friends, family, stockbroker, finance advisor about our personal finance and investment decisions. In order to solve this problem, we created Pillar Social, a social media dedicated for personal finance and investment. And here's a video.
Based on our market research, based on our extensive market research and survey, Pillar Social incorporates popular features from Facebook, Instagram, and LinkedIn. We've also implemented new features specifically designed for personal finance and investment. We also used advanced software architecture to develop Pillar Social. By using Facebook React.js and Google Firebase, Pillar Social is able to provide attractive website and extremely secure database. In order to create an engaging community, the Pillar Social also consider the user interactions and also the security consideration. For example, if a user wanted to discuss the TESSA stock on Pillar Social, the user must own or previously own the TESSA stock. In order to create an investment post, this will prevent potential investment fraud and misinformation. In order to create an engaging community, the user interactions is also considered with features such as post, such as comment, post, upvote, and share. In terms of privacy, the Pillar Social is also considered that the users in Pillar Social is in complete control of their personal information they have with Pillar. They could either share, hide, and show their post, and also show off their investment achievements with Pillar by using our unique rating system, which generates abstract rating and percentages based on their past investment performance on Pillar.
In summary, Pillar Social provide a safe and engaging community for users, provide top-class security with Google's database, and give users complete control over the data they would like to control. Despite offering many attractive features on Pillar Social provide an incredibly low cost for development and maintenance. Advertisement will cover all the costs for Pillar Social. With a combination of one of the best low-cost online broker and a social media for investment, Pillar Social will be able to Pillar Social will provide a community for everyone to talk about their investment on a global scale. We believe the future of personal finance is not about trading platform, but a community for everyone, for people, for a new generation of investors. Thank you.
Do we have any questions from the judges?
Have you tested this platform with anyone?
Yes, we did. We used the agile software development process, which we do internal tests, and we also send out survey periodically based on our progression of our prototype to users. And the agile development process is in a cycle of 2 weeks, so we test our product every 2 weeks. Yeah.
I'm interested in the pain points. In one of your first slides, you showed that financial conversations and transactions still predominantly happen in telephone or mail or fax and so forth.
Yes.
So what were the key pain points you discovered about your users, and how did that kind of determine the features that you included in your solution?
So yeah, actually all the customers in the world actually care about their personal information, especially when we talk about the money, especially investment, right? So people usually talk with their family, their friends, their close friends within like the physical thing, face to face. They are afraid of talking about this thing online, which the one problem is that there's lack of trust software online. So that's the problem. So we build a Pillar Social to create a secure place for all the investors around the world so they can communicate without any fear. Yes.
Yeah, I would like to also add on. This social media platform is developed for new investors as well, because new investors usually don't have the connection with people, so they don't have friends that usually are really good at doing stocks. So expert will only talk to the expert, and the beginners will only talk to the beginners. That's the problem with the finance market today. So we want to create a community for everyone to communicate. So the beginners can talk to the expert in the future. Beginners will be able to talk to the expert on social media platform and connect with these people to learn about how to invest. And then we'll have more people that will be able to achieve financial independence because of this. So this is more of like creating a community for everyone. So a fair and safe environment that allow everyone to invest. Yeah.
Can you tell us a little bit about what you consider is your technical edge? How easily could a competitor replicate what you have?
Yeah, based on our market research, this is actually a unique social media platform. No one has ever done that. So it's like a specialized social media platform for personal finance and investment. Yes, a lot of companies are trying to do this kind of idea. For example, eToro, they're trying to implement a social media feature in their website as well. But their social media is more of like a generic social media, like for Facebook. So their social media is not really really useful in this sense, because people will have other options such as Facebook, which has been there for 20 years already. These kind of platforms don't provide the security and these kind of like finance information and this kind of a secure layer that we build on our database. So I think that's what stands out with Pillar Social.
So one other question then, for your solution, how do you define success?
We define success by analyzing if we're able to beat our similar competitors in the first year of launching. So we did a little bit of our research, and we looked at other companies such as eToro Plus 500, and we looked at when they launch, what do they have, and how they attract customer, and is there anything that our launch product will beat eToro and Plus 500 in this sense. So we're offering much more just than investing. We're actually providing a community, and we believe Pillar Social will attract user. For the Pillar Investment platform, and the Pillar Investment platform will also attract user for the Pillar Social. So it's like a 1 + 1 more than 2 situation. So we believe this is what we think success is a success. Yeah, in terms of comparing to other competitors. Yeah.
Thank you very much.
Yeah, thank you.
Thank you.
Hi everyone, my name's Zoe, and I'm going to start off today by telling you all a story. This is my little sister Lucy, and a couple of years ago she was refereeing a soccer game. Towards the end of the game, one of the teams scored the potentially winning goal, but Lucy suspected an offside, so she called no goal. The coach of the team suddenly fired up. He stormed on the pitch and started abusing and verbally assaulting my 13-year-old sister. Luckily, some parents rushed in and saved the situation before it got worse, but that was the last game that Lucy ever refereed. Now, there are thousands of games that happen on a given weekend in New South Wales, and social sports is currently experiencing a double-digit growth. The referees making these games possible are left unassisted and end up making uninformed decisions. This leads to them getting abused. We're here today with a prototype that's going to solve this very issue. So FAREE is our video assistant referee tool. FAREE provides the ability to get footage real-time on the referee's arm. Whilst FAREE is on the field, you can be assured that your referees are of higher quality and every decision is more accurate. This is not the future, this is right now. So I'm going to go through 4 components of FAREE today. Let's start with our camera system. So these cameras will be placed at 4 points around the field. They can record all critical areas of the field in high quality. They're placed on our stands, which can recover and reorientate after impact. So all of this footage is going to be sent to the device on the referee's arm. They can navigate to any camera at any time with just a touch of a button. And all of these components, they fit right here inside our transportation case, which also has an inbuilt charging system. Then finally, we have the FAREE online web portal, and this is where all the footage can be reviewed after the game. This is going to be an invaluable tool for referees and players to get feedback and also provide a chance for referees to have irrefutable evidence of any abuse that happens on field. So, whilst I've been talking, FAREE has actually been watching. Should we review what the judges thought of our solution? I think so. Let's find out. So right now, I'm going to navigate through our app and select this camera right here on stage. Once I select a time, I can then click go, and we can see the footage come up on the screen. Can you see that? Looks good, Laura? Awesome. Looks like there's no foul play there. Let's move on. So it's clear to see that our opportunity in the amateur sports industry is massive, with over 7 million sports clubs worldwide. Now, how many people in Australia do you know that don't play sport? Let me tell you, it's not many. And with Sydney being the tech and sporting hub of Australia, it's going to be a great place to launch FAREE into. So we estimate that each unit will cost approximately $800, and the operating cost is $2.50 per game. If this was transferred onto the player's registration, it'd be as little as $1 extra per player. How achievable is that? So in terms of competition, this currently exists in huge stadiums and costs upwards of $60,000. This exists in technology that you might know, like Hawkeye in tennis, AFL score review, and in the FIFA World Cup. We plan on taking these $60,000 systems and fitting it right here inside our beautiful garbage bin. So we have gotten overwhelmingly good feedback from referees, from coaches, from players, and from sports club administrators, who are all keen to start using FAREE in their fields right away. We've also been in contact with a number of private schools in the local IGSA and GPS competitions, and we're going to stay in touch with them to start using our prototype in some of their training games coming up. So FAREE is ready to launch. We've built it, I've shown you the tech works, and the market is wide open, and the user feedback is amazing. And you know that our team is the ones that can deliver. With our wide range of skills and also the over 10,000 hours we've personally committed to sports. So help us change the very experience of being an amateur referee and stop referees like Lucy ever getting abused again. Thank you. Any questions?
How much of the field can it actually see?
Exactly 87%. So there are 4 blind spots. Thank you very much. So we'll have a camera in the center point on each sideline, and there's a blind spot to the left and right of each of those cameras. Because it's the center of the field, we're making the assumption that referees will always be able to see those positions. And yes, we can extend the number of cameras to cover those positions, but of course it increases the cost of the system.
Sure. Awesome. Thank you.
What technical considerations have you thought of that your other competitors haven't?
Well, the big thing is that our competitors in the amateur space are trying to improve the quality of referees by increasing training. So that's training programs for referees, trying to improve their calls, make them more confident with the decisions they're making. So technically, our solution is completely different. We're using technology to record the game and assist the information that they have access to. And they're our main competitors in the amateur space. We have the professional competitors, which don't compete in the amateur space.
Have you tried anyone tackling one of them?
We have kicked soccer balls at our camera case at fairly high speed, and it's maintained. Yeah, it's very durable. It's through multiple iterations to start. We did snap a couple enough that our final product is very durable.
This is also usually plugged into the thing, which makes it more secure.
Yeah, so the spike goes straight into the dirt, and it's actually more secure that way.
Go ahead.
So I'm going to ask about the cost slide. What does the $2.50 per operation cost per game?
Yeah, so I'll explain what the $800 cost is as well, just while we're there. So currently our prototype to build cost us $1,700, but that's using all the materials at retail cost. So when we can expand that to a more commercial scale, and we're building a lot more systems, we envision that coming down to $800, not using Raspberry Pis. They have way more functionality than we need. So using smaller custom-built computers for that, and that will bring the cost right down. And then the $2.50 itself is purely data storage or video storage of filming it. There's no cost for running it in the game. And so the $2.50 is storing the 8 cameras worth of footage for 1 month after the game. We envision a subscription-based model that clubs can opt in and out of how long they want to store it for, if they want it for a year or 3 months. That all depends, so that is variable, yeah.
So just to be clear, the reason we're storing it is that there's a referee review system after, so that you can go onto the portal and actually watch the entire game. So the players will also be able to log in and see their play. Parents, in case there's referee abuse, that's all accessible through the portal.
Sure, great, thanks.
All right, thank you very much. Let's give a big round of applause. I'd now like to invite Assistive Technologies and Seating Team 1.
Testing. Okay. So good afternoon, everyone. We're Team CC from ATS1. I'm Gia, and that's Alfred, and we'll be happy to present to you what we've been working on assistive controllers for like the past few months. I have to hold it down, but okay. So firstly, some background. So firstly, what are assistive controllers? Assistive controllers are just basically things that help people in their daily lives. Some probably more common ones that people are more used to are forks and spoons that help you eat your food, or maybe like a chair which helps you sit down comfortably. So why assistive control is important? So for people who have more functional or cognitive deficiencies, such as the lack of their limbs or the lack of speech, assistive controllers help give them independence in life. Assistive controllers help them live the life the way they want by allowing someone without the use of their legs to move around by using a wheelchair, or maybe someone who lacks the ability to speak, being able to speak using text-to-speech. So, what's the current issue? The current issue is that assistive controllers nowadays require users to utilize specific interfaces. Some common examples are using a joystick to control your wheelchair, a sip and puff switch to maybe push a button, or actual buttons instead for people to use. So these interfaces are not widely applicable to most users. Like a person who doesn't have the use of their arms and legs can't exactly use the joystick to control a wheelchair. So this is the aim of our team, to increase the options available by creating a portable assistive device that utilizes only the movements available to high needs users. These movements only available using the head movements as well as torso movements such as the shoulder. So this is where our device comes in. This is our device CC. CC sits on the shoulder of the user around here. CC controls 2 thermal cameras that point up at the chin of the user, as you can see probably on Alfred there. And this accelerometers that sit on the shoulder of the user. The thermal cameras are controlled by some neural network that gives cardinal directions to the chin. So let's say if your chin's facing forward, the neural network will read that you're trying to move forward. Additional options are added to the accelerometers for the user to have additional inputs. They can use it to maybe stop the wheelchair, start the wheelchair, or maybe do other things. So we'll have a quick demonstration from Alfred here when he's ready to set up. He'll be driving around the wheelchair and showing you how it works. If you matches that up. All good? Okay. Yeah, you're good? It's all plugged in? fell off. I did. Oh, okay. You good? Yep. Sorry, we're having some technical difficulties. The IMU fell off. Yeah, you're good. Oh, you crashed. Maybe we'll just go back to it later. It seems like the software crashed. So I'll just go through the rest of the presentation first. Maybe we'll come back to it at the end. So what we'll be looking first is what we've done throughout the entirety of our project. So our team has designed a non-contact method to access function and switches for users. This is by utilizing thermal cameras on the chin to control an XY plane movement, as well as the use of IMUs on the shoulder so that the users can click buttons or control switches. The machine learning software can determine chin location in the 4 cardinal directions, up, down, left, and right. This is an sort of updated proof of concept compared to the normal chin controller that people use to control joysticks. So it's a physical contact thing on the chin, and they move their chin to move a joystick. So what we aim to achieve in the future is increased functions. Right now we're controlling a wheelchair. The software can be manipulated to move such that the user can instead control a mouse pointer. They can use their chin to control a mouse on the screen with their use of their IMUs to press buttons on the mouse. What else we're trying to look at is probably more battery power for more portability. The current device is wired to like a laptop right now, as well as a Raspberry Pi and Arduino for power. By adding a battery function in the future, it'll be more portable for the user. It'll be also less hassle. Like we've done an interview before at the beginning of the project. It told us that the users wanted something that was more comfortable, something that was more non-contact, and something that wasn't in the way. The current assistive controllers are all over the place for users. They're either a slip and pulse switch that's always in the face of the user, or they're always something they have to press on the side, or something that's always beeping. So something that's more comfortable and more accessible and non-contact as a device such as CC is something more usable in the future. You ready? Oh, sorry, we have some technical difficulties. But otherwise, if you guys have questions, yeah, feel free to ask now. Yeah, unfortunate.
So what are your kind of criteria for success, and how have you tested?
Our criteria for success in terms of the user device is just that it kind of works, because our concept is to branch out such that people who need assistive controllers, even though they don't have arms or limbs to utilize what's currently available, can use our device. As long as we manage to successfully give that out, it'll be like our success, like our definition of success for our device.
How much power does it use?
I think the motors only utilize at most 5 volts, so it's powered by the Arduino. It can go down to 3, but since the Arduino only supplies 5 volts, that's like the criteria that we're using.
How far back does it sit on the actual person who's wearing it?
It's like right around here, right underneath the neck, like in the middle, and like above the arms in general, yeah.
So most wheelchairs have a back, don't they? So it wouldn't be uncomfortable?
The current design's a bit more uncomfortable, but we've been experimenting with a CAD design that's more flush to the back, and then it'll be slightly more comfortable, and once we kind of work out the kinks, it'll be a lot more flush to the user's back, so it won't feel as annoying.
You could probably just flip it over the back of the wheelchair though as well, couldn't you? Or
oh yeah, we probably can, yeah.
Cool.
Oh, you good? Oh, it's frozen. Oh, unlucky. I'm sorry, but his laptop is kind of dead.
Technical difficulties
Yeah.
are part of the...
Can I ask, how sensitive is it to the positioning?
So the positioning of the head is usually determined by the training data that the neural network actually inputted. So as it reads your head, the more experiences you go through, the more robust it is to positioning. So you can theoretically calibrate it depending on what you need.
I guess, yeah, the question's more about positioning of sensors. But I guess what you're saying is if you train it with lots of different sensor positions,
yes,
and with calibration, you can
yes,
overcome that. What's involved in the calibration? Does it take very long?
It's just so what we did was we took numerous photos of our heads in the left, right, upwards, and downwards position, and then we inserted those images. So we took around like 500 images for each position into a neural network, which eventually learned and trained itself to recognize those positions.
Have you got some sort of a switch that they can press or initiate to stop all of the movements in case they need to?
One of our current setup here, if it worked, was that the IMU toggles through forward, backwards, and neutral. We were thinking of implementing another IMU that just acts as a kill switch as a safety feature, but we just didn't have the time to implement at the current moment. Sorry about that.
Thanks.
Thank you very much. Let's have a big round of applause. I'd now like to invite up 5B.
Good afternoon, everyone, and welcome to our presentation. We are the team representing 5B in this year's Maker Games. My name is Sam, this is Tommy, this is Eunice, this is Sumanth, and this is Yusuf. 5B has developed a unique, foldable solar array design called a Maverick or a MAV, as you can see here in this video. These MAVs allow 5B to rapidly deploy their solution in remote locations such as the Australian outback in only a matter of days rather than weeks. These panels can contain up to 100 solar panel units and have an area of 200 meters square. Unfortunately, due to the environment that these panels operate in, they require cleaning. They require cleaning to maintain the efficiency of the solar farm. Without this cleaning, the company using the solar panels can incur costs of up to $100,000. Now, presently, 5B uses human labor to clean these solar panels. This can cost up to $60,000 and more for every 100 solar panels cleaned, or your average large-scale solar farm in a 6-day period. Now, this is slow, this is expensive, and the harsh environmental conditions pose a significant health risk to the cleaning staff.
Alternative solutions that we've considered are fixed sprinkler systems. While this is cheap and easy to maintain, the implementation would be permanent and immobile. The installation will have a lengthy construction period, which would contradict the quick deploy MAVs. Sorry about it. Will contradict the quick deployable MAVs. There are also robotic solutions in the market, but they're incapable of traversing over the crests and troughs of the MAVs. We would like to introduce our solution, an autonomous robotic cleaner, the SolarBot.
So our current solution, our current prototype is a scaled down 1:5 version of our final design, which you can see behind us. So features that make it unique include a variable speed brush, which can rotate up to 10,000 RPM. Motors attached to the brush housing, which can change the angle of the brush to adapt to the contours of the panels to apply consistent pressure throughout its operation. We have a unique 4-track design that allows it to traverse. The unique 4-track design that allows it to traverse across the troughs and crests. There you go. So current market solutions cannot do this. So current robotic market solutions cannot do this. And this is something that's unique to our solution. Also, it has a battery that can be easily accessible for users, allowing users to easily change the battery without significantly hindering the operation. So now you've seen what makes the SolarBot unique, but how does it perform? Through sensing the edges of the panel, sensing the tilt of the panel, and sensing the location at all times, SolarBot is capable of autonomously planning the path to cover the entire MAV with minimal human assistance. So we put our small-scale prototype on a full-scale MAV at 5B's head office, as you can see in the video behind us. It's capable of cleaning with minimal hindrance, moving up and down this panel effortlessly, and to be able to move across the crests and troughs, which are full scale. Now imagine what a full scale solar bot can do with your help. Now you've seen what our solar bot is able to do, let us show you some numbers.
Right, so SolarBot has a minimum battery life of 2.5 hours. It can effectively clean 4.5 MAVs, which is equivalent to 400 solar panels per battery cycle. It has been tested on heavily dusted panels with dirt and debris. It can travel up and down the solar panels with a slope up to 30-degree angle and is able to traverse across panels with a gap up to 10 centimeter. And finally, its autonomous functions allow cost saving, which is enabled by potentially one person controlling multiple robots at the same time with a mobile device. We expect SolarBot to cost approximately $15,000. This is based on a material cost of $8,000, and the rest is accounts for overhead such as manufacturing and design cost. So the current solution, which requires cleaners, costs approximately $120,000 each year. This is to clean a farm of 100 MAVs. On the other hand, our solution costs only $45,000, which only require three solar bots on the same farm of 100 MAVs. At this rate, we will become profitable in less than a year. So our vision is a greener energy industry harnessing the maximum potential of your solar panels, which is held back by dirt and debris. This is the solution. This is SolarBot. Thank you for listening. If you have any questions, please ask.
Required?
I think a maximum of 2 to 3 operators are required for a farm of 100 MAVs.
Yeah, so for example, with the setup you have here, what's to say I'm going off the edge of the roof versus I'm going down the slope to get up another one?
Okay, so at that stage, for our final design, we've envisioned that it'd be around 20 kilograms. So that'd be a two-person job to just lift one SolarBot and move it to another MAV. So
how does the SolarBot recognize the end of the roof?
So there usually will be ultrasonic sensors along the edge, and that can detect the edge and it will stop there, allowing it to turn. And you've seen the simulation. So it detects the edge using the ultrasonic sensors and then turns and then moves back.
Okay, so that's not requiring any human interaction?
None at all.
Thanks.
Does it actually clear the debris or does it collect it?
So it clears the debris, but we do not have a collection device. No.
So the dust kind of just flies off?
Yeah.
Is that?
So
Okay. Doesn't come back down on the panels again?
When we tested it on the full-scale map, it did not do that. But we are thinking of if we do build a full-scale robot to have a water gun in it as well, and that will guarantee that the dirt will just move off the solar panel.
So what functions have you got in the prototype there? You don't have the full autonomy, is it?
We don't. So we had issues with the IMU because it's not accurate enough with the budget we had. So we had things like IMU drift, which restricted it from going in a straight line. Right now we have full human control. So as you saw, we can move across the panels very easily. And we have some edge detection. Yeah.
What's the longest period of time you've tested it for, and what happened, I guess, during that time?
Half an hour. And we saw that, well, the video you saw was it's the longest time we tested it. And well, we cleaned the entire panel very effectively. The problem is that because it's a prototype, it's a lot slower. So usually we expect the full-scale design to be a lot bigger. Yeah, so about 1 meter long. And that would clean the panels a lot quicker, which allows us to reach the 4.5 MAVs or 400 solar panels in one battery cycle.
So with that figure, does that assume that it covers any area twice?
No, we just have one pass through. Of course, we can program it to cover it twice. That would reduce like the number of solar panels that it cleans and make it take longer, but it would be thorough.
Sure.
Can I ask about the weatherproofness?
The weatherproofness. Okay, yeah, so there's a lot of dirt, so which means that we have to be careful about the wires, electronics inside it. So that's why we were planning on sealing the electronics in a casing, much better than our prototype. And that we hope will protect it from the outside weather.
Are there any more questions for the judges?
The only alternative or the primary alternative is manual, is that correct?
Yes.
Thanks.
Well, thank you very much. Big round of applause, everyone. Jacobs, all right. Jacobs to the stage, please.
Good afternoon. This is Embray, and today we're here to present our solution to one of Australia's biggest national issues, protecting people and their homes from the threat of bushfire. On New Year's Eve 2019, my grandpa and his neighbour were on that ridgeline of the New South Wales South Coast, fighting fires to protect their homes. The genesis of Embray were based on the needs that they needed that night and that no current market solution solves. The needs being, 1, a system that conserves water. Bushfires operate in drought, and homes that are not connected to mains water do not have an unlimited supply to fight fires with. 2, a system that is as good, if not better, than a human at locating and detecting embers and extinguishing them, to eliminate the need for human participation. 3, a system that remotely connects homeowners to their property to reduce their anxiety while waiting to return to it. And 4, a system that connects firefighters to homes so that in the event that they do catch fire, they might be able to be saved. We believe we've developed a product that solves these requirements.
Our solution is Embray, a smart bushfire sprinkler system. Embray consists of a sprinkler array, a solenoid control box, a diesel pump, a green battery, an internet-enabled CPU, weather sensors, and most importantly, a thermal imaging camera retrofitted to the house. How it works is as follows. Embray scans government websites for information relating to fires, including fire risk and active fires within a 30-kilometre radius. If a threat is detected, Embray alerts the user to set up the pre-established sprinkler array around their property. Embray splits the property up into grids, much like a chessboard. When a threat is determined in any one of the grids, Embray actuates only the relevant sprinklers, containing the threat and protecting the home.
We have developed a minimum viable product that is capable of detecting fires and actuating a response. The videos on the right show Clinton walking around in different zones in front of Embray with a blowtorch. The close-up view shows that as he enters each different zone, the appropriate sprinkler switches on for 3 seconds before turning off. This feature not only allows us to save as much as 3 times more water than traditional bushfire sprinkler solutions, but also allows the whole system to work autonomously and without the need for human intervention. This is all possible because different fires in every grid surrounding a property can be fought simultaneously.
Embray connects users to its in-house mobile app as seen on the left. If the system is live and the property is at risk of a bushfire, homeowners can stream a live feed of the thermal imaging camera via the app. The ability to monitor the feed will therefore mitigate the stress of not knowing the state of your house while you are evacuating, and ultimately deters homeowners from staying behind and to protect the house.
Embray will be connected to firefighters by providing real-time wind, temperature and humidity data to the real fire service. With more data, more accurate weather models will be able to be produced before entering a bushfire. This will allow local crews to better pair and manage resources during a bushfire. With more effective allocation of resources, more houses and people can be saved.
While some of the features we have discussed are already accessible on the market, not a single product combines this new technology and the interconnectedness with the state and local government. Rolled into one package and strung together with our algorithm is the reason why consumers will turn to Embray as the industry leader for comprehensive smart protection of the house.
Over the next 5 years, the projected revenue of Embray is $1.6 million, with expenses at $1 million. Our positive MPV, calculated at a 15% discount rate over 8 quarters, is a strong signal to future investors of the future profitability of the company. It is for these reasons that Embray is the first bushfire sprinkler system to be endorsed on a conceptual level by the following government agencies and users: Fire and Rescue New South Wales, the Californian Fire Safe Council, the New South Wales RFS, and the Honourable David Littleproud, Federal Minister for Emergency Management.
We believe that we've developed a product which conserves water, is more effective than humans at locating and extinguishing embers, remotely connects homeowners to their homes, and connects homes to local firefighters. These features will ensure that my grandpa, his neighbour, and millions of other Australians will never have to compromise the safety of their home or their lives to protect their house from bushfire. Thank you.
Sorry. So, just so I understand the solution correctly, there are 2 different parts to it. There's the sensor-driven sprinkler system, yeah, and the thermal imaging camera is separate to that.
So the thermal imaging camera is basically what allows us to detect threats better than any human can. It scans the whole property and it can see through smoking conditions, which is an issue that's, you know, really a lot of firefighters struggle with because it senses the heat rather than a visual signal. And that allows it to actuate only the relevant sprinklers. The current market solutions indiscriminately spray the whole property, so they wet areas that aren't even at risk and they waste water. What we found in our initial research was that a lot of properties that were really devastated by bushfires this year were running on, you know, their tanks were almost dry because it was in the middle of Australia's biggest drought. So we need a system that actually is really, really water conscious, but still very effective. So that's what the thermal imaging camera provides.
And just to add on that point, the RFS, so a lot of people choose to stay behind to protect their house, which is what the government say you shouldn't do. If people would leave 4 hours, 5 hours before a fire front with their families to put themselves out of harm's way, they run the risk of running their sprinklers and coming back, even if the fire hasn't passed, now they don't have any water. And so if the sort of a future, bushfire front comes, or if they need a shower or use, they've got farms and cattle, this is where the water conserving feature really is an important and critical aspect of this product.
On this topic, have you done any research or have you engaged with anyone from the Royal Fire Service or anything like that? The reason why I ask is, just from what you're asking, how do you know how much water you need and how far away is the fire from when you trigger that amount of water, and have you quantified that amount of water that you need?
Yeah, absolutely. So we actually worked and partnered with Fire Rescue New South Wales. So we actually took the idea to them, and then their feedback, we sort of went back and forth and incorporated it in multiple revisions. They said that, and most traditional bushfire sprinklers run at 3 litres per minute, which equates to about a 30,000 litres, which they said was the standard that they sort of assume rural properties who are not connected to mains water would have. That's the flow rate when they sort of say you should go to Bunnings, or you should, they tick off on different bushfire sprinkler systems. That's the sort of minimum flow rate that they need. Where our water saving comes from is that when sort of bushfires are propelled by wind, and so wind will actually push, so one side of the property will be extremely vulnerable and much more likely to be affected by embers than the other side. So that's where our water saving feature comes from, because we can concentrate the water where it's needed.
So you verified that the amount of water that is required to protect the property is matching and aligned to the temperature that you're reading with the thermal imaging camera.
Yeah, exactly. In addition to that, just Nick, if you want to click forward a couple of slides, we use the fire dynamic simulation. Also, huge thanks to our academic mentors that provided us with these tools. But we use the fire dynamic simulator with the PyroSim interface.
Nice.
We built models. Obviously, it's quite dangerous to light a bushfire for obvious reasons. So we built extensive CFD models of fires and simulated our sprinkler system in that environment. And by all metrics, it was successful at putting out all the threats that we thought it could encounter.
Thanks.
Can I ask, how many of the sensors would you need to cover, a typical property?
So for a typical Australian property, the height's 3 metres, and so we would say swiveling at a 270-degree angle, you need minimum two things. Of course, when we go to sell this product, different houses have different requirements. They're, different landscapes. They have already, in sort of our product, we want to try to be as accessible as possible. So what we're really selling and our core IP is the detection and algorithm system, which is able to conserve the water. So if they have, already sprinkler arrays or different cameras or different vantage points, we can utilise that.
And where's it installed on the property?
Just on the gutter line. So just above the gutter line. Unfortunately, we had some technical areas in there you couldn't see in that, I think, third slide. But we have, they do have blind spots. And so that's where we use more traditional thermal couples and thermal heat sensors just to make sure that we're covering those blind spots in case they do get hit by embers and the camera can't detect it.
So on the edge of the roof is very easy for installation, which is great. But what about the roof itself? Because the embers can settle on the roof and catch a light there.
Yeah, so as Nick was saying, to completely cover the property and provide that full protection, we also utilise normal just temperature, like thermocouples that just sense the temperature in one area. So we'd have those along the gutter line and also along the roof line. So that enables the whole property to be covered. The real threat with ember attacks is the lawn area, the garden area, and the roof area. So that's what our system really targets. The blind spots, like Nick said, are also then filled in with these cheaper, less high resolution cameras.
So is it, just to be clear then, so your solution includes the roof or is compatible with something else that would operate on the roof?
Yeah, I mean, they're retrofitted to a house. So our business model sort of comprises, we have technicians, they're going to come in, they're going to assess it. And if they, determine that the gutter line isn't appropriate, otherwise, if there's another vantage point that might access, they will have to, it's a case by case, no house is the same.
Okay.
Thank you very much, everyone. It's a big round of applause.
Just while we have everyone's attention, we'd just really like to say thank you to our Jacobs mentors. Also, we'd like to say thank you to Kevin and Deepan. You guys have been amazing. Everyone else on this slide, our academic mentors, we really appreciate it. We had a great time. Cheers, guys.
On team. A big round of applause, please.
Thanks for your patience. There's a bit of logistical issues trying to log 120 litres of water across campus, but we got it here. Now, just to quickly start, I'd just like to start with a short survey. How many people here have ever searched for anything on Google? Okay, that's pretty close to what I expected. Not as high as I thought, but pretty close. Now, how many of you have ever stopped to think, how much energy did that search just use? So the answer to that question is 2,260,000 megawatt hour per year. Now that is a big number, and that's the amount of energy it takes for Google to run all their servers throughout a year. To put that in perspective, that's the equivalent of powering 200,000 homes for an entire year. Now, the reason that number is so high is because traditional data centers use air-cooled systems. What that means is they have a large room like this, put a bunch of servers in it, and cool it using air conditioning. Now, this is very inefficient energetically, especially in warm climates such as Australia, where it takes a lot of energy to cool down that air. Now, because of this inefficiency, the data center industry is responsible for 2% of the world's carbon emissions, with that expected to double within just 4 years, as the data center industry is one of the fastest growing in the entire world. Anyway, because it's such a big issue, many companies such as Facebook, Microsoft, IBM, they've invested billions of dollars into this industry to try solve this issue. In fact, earlier this year, Microsoft put a whole data center underwater just to try keep it cool. Now, the use of fluids to cool a system isn't completely new. In fact, there's a technology called immersion cooling, which essentially involves putting servers into a dielectric fluid and carrying heat away that way. This is far more spatially efficient as the density of the fluid can take away far more heat. However, it's not a perfect system as the whole tub needs to be cooled just to cool the servers.
The problem with cooling down an entire tub or even an entire room just to cool down a few servers is that the heat load of servers varies over time. So for example, if one server is processing too many Google searches too quickly, it heats up and it needs to be cooled down. The traditional approach is cranking up the AC to cool down the air in the room to then cool down that one server. This is extremely inefficient. This is where our solution comes in. Our solution offers targeted cooling. It is an immersion cooling solution that has dedicated side inlets to each server. So for example, when that server gets too hot, you open up that side inlet and the fluid flows directly into that server. While we've been doing this, hopefully, no, ideally, our prototype would have been running a baseline test where we have just the inlet and the outlet open, so that would be just a basic fluid flow going through. We're going to take a temperature reading of the outlet and the inlet, take the difference of those temperatures, and that would represent how much heat was being removed from our servers. We were then going to implement our targeted cooling technique where we would open the side inlet that is directly next to our hot server. So 3 of the servers are currently idling. Yeah, 3 of the servers are currently idling and 1 of them is running at a high heat load, so it is very hot. When we open up this side inlet, the fluid is flowing directly over it, and then we're going to take another temperature reading of the inlet and outlet, and if there is a bigger difference, it shows that the water is taking more heat out of the servers, and therefore it is more efficient because we are just distributing the fluid flow between these 2 inlets and not increasing it overall. Can we take a temperature reading? So how we're changing the fluid flow in our prototype, we're using a 4-way tap and we're just opening it up and that's distributing the fluid flow around. In a full model, this would not be the case. We would be using a PID controller that would automate the system. It would take temperature readings from the servers directly and use these to then control solenoid valves that are at each inlet. How are we going with that one? Fantastic. So now can we change the flow around? So we've got a targeted cooling. Fantastic. All right, we'll just give that a couple of minutes to just try and get a difference. Another main thing that we have with our design is the maintenance of servers. So to maintain servers, it's actually a really hard thing with immersion cooling. Traditionally, there's no fluid flow, so you can just take the servers directly out, put it on a maintenance tray, and then do the service there. But because we have fluid flow, we used a canopy that was a great solution for cable management because all of the servers would be suspended above, you can see there. And then using a pulley system, the operator can pull the server out of the water, move it across using a platform that's above that has swivel wheels so it can move in all directions, and then lay it onto a maintenance tray. Can we now take the temperature readings for this setup? Yeah, you've done it? Fantastic. Is there a bigger difference of temperature? Yeah? Yeah, fantastic. So that's our proof of concept that targeting the fluid flow does indeed have a greater cooling efficiency than just having a basic fluid flowing through. So by offering this targeted cooling solution, we can help companies that rely on using the cloud to store, say, for example, their footage for their referee to view on the field. This would be immense savings for everyone as it greatly reduces the cost of data centers. And because by 2050, it is calculated that 1/3 of the world's power consumption will be spent on cooling data centers, even just a tiny change in efficiency here will result in immeasurable costs for data centers in the future and will lead to a brighter and more sustainable future. Thank you so much for listening to our presentation. Fantastic. Are there any questions?
Have you got any numbers about how the water compares to the air-cooled system?
So with using, we actually wouldn't be using water. It's actually would be using a mineral oil. It's traditionally what's used, so that because water and electricity don't mix. But in terms of prototyping, we didn't want to drag a whole lot of mineral oil. Water is bad enough on this stage. And so for our project, it was just a proof of concept of how we can change, like how we can improve the efficiency of this system, because the efficiency of an entire data center relies on how you're then cooling that water or that liquid and everything. So for us, it's just showing that there is a more efficient way of using immersion theory.
So you're basing the more efficient on, so sorry, I should have clarified the numbers.
Yep.
So cost-wise and energy-wise, do you have any kind of statistics or numbers around how that compares to air cooling?
The initial capital cost would be much more because you have to completely redesign the data center. However, this is more looking at the scope of having a third of the world's power usage being used to cool these data centers, and it is just on the cooling, it is not on the initial capital cost. So if we can better cool these systems, we're predicting that there will be a much more economical option for companies in the future.
Into the air cooling systems?
Yep, so obviously with our prototype it is not automated at all. You wouldn't be using that four-way tap from Bunnings. It would be using that PID controller, and so by taking the direct temperature readings from the servers, then as the inputs to that system, and then there would be solenoid valves which can change the flow rate from those side inlets, and so yeah, it would just be changing it as it's going. And there's actually a massive scope for that, with a lot of companies in data centers at the moment employing machine learning, and so they could monitor the whole system and further optimize their data centers for their needs.
Is there any spill risk? Like you're talking about a liquid?
So yeah, again, ideally the tub wouldn't be from Officeworks.
No.
No, and there would be a lid, and so in immersion cooling at the moment, the operators, when they're taking it out, have to wear protective equipment. However, with our canopy and our maintenance system, lifting it out would allow all that fluid to drip off into the tub before they place it out, and then they can safely move it onto the tray next to them.
I had a similar question about maintenance. So does that increase the maintenance cost?
Of the yes, very slightly. So we would have the electric motors that could be automated by the operator, or then as a redundancy option to that, because server maintenance is so important, there would also be a manual thing. So if they wanted to just use the manual, it would just be the initial cost of setting up the canopy.
Yeah, I guess I was thinking relative to air cooling, but yeah.
Well, to air cooling, you could say that the maintenance for air cooling is reliant on the server racks being there, and the cost of those server racks is immeasurable. Well, it's not immeasurable, but it's a lot. It's a lot. So no, not really.
Okay. And just one other question then. So, I mean, computational resources could fluctuate, instantaneously, basically. So how quickly can you get a change in temperature through your cooling system? And is it faster or slower than air?
Much faster than air. But just purely because of the density of the medium.
I think another thing to point out with that is with air-cooled systems, they generally, it's very hard to employ that kind of system because you have to cool the entire room. You can't really direct air into a server and cool it. It's just not efficient enough. Air's not dense enough. It won't carry away enough heat. So yeah, it's not really even possible with air, to be honest.
Great. Thank you very much, everyone. Big round of applause, please. Hi everyone, now we will be commencing the final part and presenting the awards now. So first of all, congratulations to everyone here and all the teams who have presented today. It's awesome seeing the projects that you've made and just how much work you've actually put into that and getting through such a challenging time. I'd like to invite Kevin and Depan to say a few words now.
Okay, good afternoon, guys. It's how ironic that most irrelevant person in the program is making the final comments, but I would like to first congratulate and thank Kevin, because without him, this program wouldn't have been there, and I couldn't have done it. You know, I got involved. I got involved in this program in March, April, so I barely had any time to know the program or prepare for it, but Kevin was almost like a father, walking me through it. I was almost like a baby, just merely an academic trying to, get people to support the program, but Kevin did the heavy lifting. So again, I would like to thank him a lot to support me through this program and run the program effectively that we have done hopefully. I would like to also thank all the academic mentors who came really, who joined despite of already probably being heavily committed to their own coursework and other commitments. Also all the industry mentors without whom the program wouldn't have been possible again, because they supported the students most, more than academics or us. Who else? I would like to also thank Julian, because he was the person who first introduced me to the program and supported in the beginning. And finally, I would like to congratulate all of you guys for very nicely, quite successfully finishing the program. Honestly, I was more nervous than you guys because I couldn't have imagined myself being in the situation and still, by addressing all these complicated problems, sitting at home, especially. And although you're working as a team, but honestly, I don't get the team feeling unless I meet my team members in person. So, but you guys did that and did so effectively, and that showed all during all through today actually. And some of you did such amazing prototypes, made some amazing prototypes. I'm pretty sure your industry mentors would be really happy. Again, congratulations and thanks a lot to all of you for making the program a successful one.
Thanks, Deepan. I'm going to keep this really short and sweet in case I get emotional or something like that. But I guess this is kind of my metaphorical mic drop for my time at UNSW and for the program. I don't have quotes of philosophers and important people from history, but I have noticed a couple of key themes of this program over the last couple of years, and those are grit and gratitude. Just a couple quick thanks. Student Opportunities team, Sandra Harrison for taking a chance on me. Nathan, Roberta, Steph, thank you. The whole Makerspace team, Mel, Rob, and Gabo, you guys are just a bunch of legends. See, it's already happening. So many students were in the Makerspaces this year. It was such a great thing to see. It's been amazing. To the judges, all of you, Julian, you know how much I respect you. You've just been an incredible mentor for me, especially in my early time at UNSW. I'm very honored to have worked with you and gotten to know you. Thank you once again for coming to another Maker Games Final Showcase. Tamara, thank you so much for donating your time, especially during your week off. You've been such an amazing friend and colleague at UNSW, and thank you very much. Good luck at getting that black belt as well. Laura, you're the first person outside of engineering that I met at UNSW when I started. Thank you for continuously supporting and being a major contributor to this program, and for the entire MCIC team and founders team for being a part of all 4 years of the Maker Games. Thank you so much. Appreciate it. Deepan, what can I say? You stepped up this year when no one did. We actually wouldn't even be here without you, so thank you so much. It's been, fun, wild, interesting year, and just a pleasure to get to know you and get to work with you. And I think reminiscing about all of our favorite all-you-can-eat sushi places, karaoke bars, and Kitchener-Waterloo Oktoberfest back in Canada, It was pretty fun too. So I'm so glad that I made another lifelong friend at UNSW, so I want to thank you. Quickly to the academic mentors, I mean, such a wild year. Deepan touched on it way better, but you know, thank you for keeping your teams on track during COVID, keeping them on time. I hope you've enjoyed the experience as well. To our industry partners, so many businesses and companies have been affected, and we've all been affected by COVID this year. I want to send a massive thank you to you, staying committed to your student teams despite everything. Yeah, for those of you who have supported this program for multiple years, thank you so, so much. And for those that's your first year, I hope this is just the tip of the iceberg. You know, despite the program concluding after today, I urge you to continue and support student programming at UNSW through another pillar of challenge or a student society. Thank you once again for being a part of the Maker Games. And lastly, to the students, you did it. Congratulations. Last year it was trimesters, this year it was COVID, and you guys smashed it. So well done and congratulations. Unfortunately, not everyone can be with us today, but we appreciate you and we acknowledge you and thank you. I hope that you've taken away many lessons in the Maker Games. If I can leave you with a couple more thoughts though, the next time you find a challenge that comes your way, look at it in the face, show some guts, go for it. You guys all did it this year. And then lastly, whenever you do graduate, don't forget where you came from. Give back just like your mentors did and inspire the next generation of engineers. I'm very proud of you all. Thanks again. Congratulations.
Before I announce the awards, on behalf of all students, thank you, Kevin. Thank you for all the opportunities that you have given us as students. Thank you for giving us such a unique opportunity to learn the skills that are so important in industry. Opportunities like this are so hard to come by, and the fact that you are giving us students amazing things to do and amazing projects to work on is something that is really special and something that none of us will ever forget. So thank you. The honorable mentions, we have Rubock. In third place, let's get a drum roll going. We have 5B. In second place, drum roll, Ignite referee, Team 2. And in first place, we have Jacobs. Now, unfortunately, due to COVID, we can't actually physically give you the award, so please do remain seated. But big congratulations to all teams who competed. It's amazing seeing how far you guys have come, and yeah, congratulations.